Hello, I welcome you to this video tutorial, and in this particular tutorial we are going to discuss about machine learning algorithms used in detection and classification of conflict flows in SDN. SDN means software defined networks. The machine learning algorithm, the second slide tells us that techniques for detecting and classifying the conflicts in SDN models are highly imperative. Machine learning algorithms have proved their efficiency and effectiveness in detecting and classifying two or more subjects. The main purpose of using these algorithms is to train and build systems that are efficiently capable of classifying subjects with high detection accuracy. We went ahead to see these machine algorithms used in detection and classification of conflict flows. One is decision tree. We have the SVM, extremely fast decision tree, hybrid, but the hybrid proves the performance of the flow because it is a combination of a DT and SVM. The decision tree, for it is implemented to handle regression and classification problems, though it is more used in classification problems. From there we went to how does this decision tree work. When you look at this matrix, we have Y is a condition factor to categorize and describe. X1 is a factor made up of category. Then here is just an illustration of this decision tree. We have priority, entropy, samples and values. If true and false, what if it is true, go to this. If false, do this, as this illustration shows. We went ahead to do the implementation. Of course, that is basically the background of the decision tree. Here we look at the algorithm, how we would have implemented it. First of all, implement the decision tree components in a control panel. Prepare and import all generated flows from open and switch to all the flow sizes. Training the algorithm with 70% and testing it with 30%. And at the end of it, we have to evaluate the confusion matrix for the DT algorithm and then calculate the running time. We also have the simple vector machine. For it is a binary supervised classifier employed in machine learning, and it is a nearly perfect line or decision boundaries to divide and end denomination area into categories. Here we went ahead to look at the VCM in a plane, and from the VCM in the plane, this is its illustration. Of course, we have different data points. These ones in blue, and this what separates is this hyperplane, the red mark. And here we went ahead to describe it, how it works like. Then we went to its implementation. It is still the same way, but the difference is that this one, the vector components are used in a rel controller and apply hard margin function. We still go through the process of preparing the data flows and training using the SVM with the 70% flows. We have what we call also extremely fast decision tree. For it, it is extremely fast. It uses the Hopford method tree generator. And when you read ahead through this tutorial, it checks whether the difference between the average information improves of the highest two parameters is going to provide a great meaning almost at any time. And here we have the two top attributes of these algorithms. And of course, this is its mathematical background and how these algorithms came all about. We went at hybrid DT SVM algorithm. For it is a combination of decision tree and SVM. Earlier we saw how the DT works and SVM how it works. And this is just a combination of two, but in this time we are going to bring in the AVR, or one versus all. Multi-class strategy is utilized here, and it consists of fitting one classifier per class. Each class is identified by one classifier. It is imperative to obtain information of the class by examining a related classifier. And here it is in its implementation. Of course, we first implement the DT classifier object with SVM classifier. Then we go ahead to implement the OVR classifier. Then we modify the OVR classifier to combine the TD and the SVM for the action and IP roles address. We integrate the TD and SVM, set up an implementation classifier to combine the prediction of TD and SVM. Still, we prepare and import flows. We also train the hybrid SVM with 70%. We saw earlier that when they are detecting the flaws in network, in software designed networks, we have been splitting the dataset with 70% for training and 30% for testing. And at the end of everything, we have to evaluate our what? We have to evaluate our model. Thank you.